10 windiest places on Earth. The Earth is in constant motion, not just in its rotation, but in the winds that sweep across its surface. These winds, often invisible forces of nature, shape climates, drive weather patterns, and influence ecosystems. Some places, however, experience winds so extreme that they are classified as the windiest places on Earth. Understanding these windy regions is not only fascinating, but also vital for weather scientists. In this video, we'll explore the science behind unstoppable winds and highlight the 10 locations around the globe where the air never rests. To understand these windy phenomena, we need to start with the basics of wind formation. Wind occurs due to differences in atmospheric pressure. Air moves from areas of high pressure to areas of low pressure. Several factors influence the strength and direction of winds, including temperature gradients, topography, and the Coriolis effect, caused by the Earth's rotation. In regions with extreme winds, these factors often converge. Open terrain, steep temperature contrasts, and geographic features that funnel airflow amplify the already powerful forces at play. Studying these windy areas helps scientists improve weather simulations, better understand global wind systems, and even design solutions for harnessing renewable wind energy. Let's look at 10 of the world's windiest locations and analyze what makes each of them so extraordinary. Commonwealth Bay, located along Antarctica's eastern edge, is often considered the windiest place on Earth. The dominant force here is katabatic winds, which occur when dense, cold air flows downhill from the Antarctic ice sheet toward the coast. These winds can reach speeds exceeding 200 kilometers per h, 125 miles per hour. The relentless intensity of Commonwealth Bay's winds has shaped the icy geography and disrupted human exploration. For scientists, this region offers unique insights into polar wind behavior and its influence on global weather patterns. Mount Washington is infamous in meteorological circles for its extreme weather conditions. With wind speeds reaching 372 kilometers per h, 231 miles per hour, this peak held the world record for the highest wind velocity ever recorded on land for over 6 decades. The mountain's location at the convergence of several weather systems, combined with its steep slopes, creates a perfect storm for intense winds. While less remote than Antarctica, Mount Washington provides critical data on extreme weather, aiding climate research and safety designs. The winds of Patagonia, the southernmost region of South America, are legendary. Fueled by the temperature difference between the Andes and the expansive plains, strong westerlies dominate this area. The unobstructed landscape allows the wind to sweep across the region at incredible speeds, often reaching 160 kilometers per h, 100 miles per hour. Patagonia's high winds significantly shape its ecosystem, from stunted vegetation to sculpted rock formations. For weather scientists, studying Patagonia offers clues about how wind interacts with open terrain. Known as Windy Wellington, this capital city sits between New Zealand's North and South Islands, where the towering southern Alps funnel the winds through the narrow Cook Strait. This unique topography amplifies wind speeds, which regularly exceed 80 kilometers per h, 50 miles per hour, with gusts much higher. Wellington offers a rare example of how a modern city adapts to a high wind environment, from wind-resistant infrastructure to urban planning that embraces the gales. Barrow Island, off the coast of Western Australia, is no stranger to extreme winds, especially during tropical cyclone events. In fact, it holds the record for the highest non-tornadic wind gust ever recorded, 408 kilometers per h, 253 miles per hour, during Cyclone Olivia. This remote island is a prime location for studying the interplay of tropical weather systems and the high wind speeds they generate. Barrow Island also highlights the devastating power of wind on infrastructure in cyclone-prone areas. Nestled along the Mediterranean coast, Gruson is subjected to the tramontane winds, cold and dry gusts that sweep down from the northwest through gaps in the Pyrenees Mountains. These winds are an important climatological feature of the region, influencing local agricultural practices, wind energy production, and recreational activities like sailing. Gruson exemplifies how regional wind patterns can significantly shape human activity and development. The South Pole is another testament to Antarctica's dominance in the world of wind extremes. The Amundsen-Scott Station experiences constant ground-level winds due to the spinning, icy air currents found near the pole. While not as fast as the katabatic winds of Commonwealth Bay, this station's persistent windiness allows researchers to study polar wind systems and their implications for global weather models. If you thought the land winds around Antarctica were extreme, the surrounding Southern Ocean takes it to a new level. Here, the notorious roaring 40s, furious 50s, and screaming 60s dominate, classified by their latitude zones. These winds are unimpeded by landmasses, allowing them to gain immense speed and force. These conditions are critical for understanding ocean-atmosphere interactions. Weather scientists studying these winds can also gather insights into their critical impact on global ocean currents and climate systems. Located in the Great Plains, Dodge City experiences year-round high winds because of its flat terrain and frequent interaction between weather systems from the Rocky Mountains and the Gulf of Mexico. This region is also home to tornadoes spawned by wind supercells. Dodge City serves as a valuable area for understanding continental wind systems and their role in severe weather formation, making it a hot spot for meteorologists and storm chasers alike. Oregon's coastal Pistol River is another zone of remarkable winds, driven by the temperature differences between the Pacific Ocean and inland areas. The strong winds have made this area popular among windsurfers, but for scientists, it's a prime zone for studying coastal wind variability. Pistol River also highlights how wind interacts with ocean currents to shape coastal environments. Although these windy places span continents and climates, they share several features. First, their geographic isolation or unobstructed landscapes amplify wind speeds by reducing friction. Second, they often exist in regions with steep temperature or pressure gradients, such as Antarctica's frozen coasts or New Zealand's narrow straits. Lastly, many of these locations sit in areas where weather systems converge or winds channel through natural formations. For weather scientists, recognizing these shared factors reveals patterns applicable to other regions of the world. These extreme conditions also provide real-world laboratories for testing theories about wind behavior and its impact. Living in windy regions presents unique challenges. Infrastructure must be designed to withstand gusts that can down power lines, erode structures, and significantly disrupt transport. Communities in places like Wellington and Patagonia have adopted wind-resistant designs and systems to thrive in such conditions. Wellington, for instance, integrates wind awareness into its architecture and urban planning. On the other hand, high winds can offer opportunities. These regions are often chosen as sites for wind farms, where the consistent airflow can generate renewable energy. For example, parts of Patagonia and Gruson are pioneers in large-scale wind energy production, offering sustainable solutions to local power demands. Wind may be a destructive force, but it is also a valuable resource. Many of the world's windiest areas have become important hubs for renewable energy, as wind power continues to grow as one of the most sustainable forms of energy. Advances in technology have allowed even remote and extreme windy locations to be utilized for high-efficiency wind turbines. For weather scientists, studying these areas isn't just about understanding nature, it's also about creating solutions to combat climate change. From observing weather patterns at research stations in Antarctica to analyzing cyclones over Barrow Island, the windiest places on Earth are critical regions for scientific exploration and discovery. Research in these locations not only helps us understand extreme weather, but also aids in forecasting dangerous conditions elsewhere. Wind data from places like Mount Washington and Dodge City allow scientists to refine atmospheric models, improving our ability to predict tornadoes, hurricanes, and other catastrophes. In areas like the Southern Ocean, research sheds light on the interplay between oceans and winds, critical for understanding rising sea levels and global heat distribution. Earth's windiest places are more than just curiosities. They are vital to unraveling the complexities of our planet's atmosphere. From Antarctica's katabatic winds to the roaring 40s of the Southern Ocean, these regions illuminate the power of moving air and its influence on life, climate, and weather. For weather scientists, these winds offer opportunities for discovery and innovation, refining predictive models, designing resilient infrastructure, and improving renewable energy systems. As we continue to study these extreme landscapes, let us marvel at the raw force of wind and its enduring role in shaping the world around us.